Hi everyone, my name is Rosiana Natalie from Singapore Management University. Today I will be presenting our work supporting novices author audio descriptions via automatic feedback. This is a joint work with Joshua Tseng, Hernisa Kacorri, and Kotaro Hara. The current gold standard of generating audio description is hiring professionals to write the audio description script and recording it. But this process is costly, both in terms of money and time. For examples, the service can go between 12 to 75 US dollars per video minute with turnaround time about a week. Prior works have explored methods to semi or fully automatically generate audio description to reduce the cost and the turnaround time. However, automated methods still lack accuracy and sometimes do not cover important information such as setting or actions that are useful for blind people. Noting that generating audio description automatically is not ready yet to generate high-quality audio description, we then ask ourselves, how can we combine automation in the process of authoring audio descriptions to increase production efficiency while keeping their quality high? To answer our research questions, we built an audio description authoring interface that combines manual audio description authoring and automated feedback generation based on computer vision and natural language processing. We borrow the conventional design of collaborative authoring tools for writing and peer reviewing scene descriptions, which consists of video player, video navigator, sourcing visualization, scene start time column, closed caption column, the scene description column with the scene description text box, and lastly, the feedback column that shows the label feedback. Using our interface, the novice participants will type their scene description in the scene description column text box. Immediately after finish typing the scene description, the feedback column will display a word cloud of interactive representation labels, and it aims to suggest the participants to include these labels to make their scene description better. To generate the feedback word cloud, we use scene understanding service to generate the labels of items detected in the scene. We use Amazon recognition to detect what are the objects and the activities extracted from the video. However, Amazon recognition generated too many labels, and definitely we don't want to overwhelm the participants by displaying all of them. For example, the simple scene that I've just shown you, by using Amazon recognition, it generated in totals about 42 labels. To filter the labels, we use the hierarchical information from Amazon recognition, and then we construct the hierarchical tree of all the labels. After constructing all the trees, we then use dbScan to cluster the trees that are semantically similar. After we have multiple clusters in the scene, we then select the representative labels of the cluster. First, we choose the tree that has the highest confidence score in the root, and then from there, we traverse the tree to select the labels that aren't too specific nor too broad. Please refer to our paper and our appendix on the selection criteria. Using such mechanism, we were then able to conceal about 70% of the labels, making it about only 7 to 9 labels per scene on average. To test the efficacy of automatic feedback in generating good quality of scene descriptions, we conducted a user study with 60 participants and divided them randomly into 3 different study conditions. The conditions are without feedback condition, automatic feedback condition, and lastly, the human feedback condition. Here, the automatic feedback conditions, the participants are given the label results from recognitions as a feedback. And in human feedback conditions, the participants will receive the review from the cited reviewers. We asked the participants to generate scene description to 3 different video types. The first one is advertisement video of Subaru car, the second one is an explainer video of color contrast, and the last one is an instructional video on how to make a bookmark origami. In this study, we aim to evaluate the efficacy of the automatic feedback in generating a good scene description. Hence, we asked the blind evaluators to evaluate the quality of the scene description. We also calculate the production time of the scene description, and we also analyze the linguistic characteristic of the scene description generated by the participants. Lastly, we conduct a semi-structured interview with the participants to understand the experience that they encounter while using our interface. Due to the time constraint, we will be only discussing the blind evaluators' evaluation and the calculation of the production time. In this study, we used the codebook by Natalie et al. That consists of 9 qualities of assessing audio description, which are descriptive, objective, succinct, learning, sufficient, clarity, interest, accurate, and referable. Let me give you one example on how the evaluator assessed the scene descriptions. Suppose for this particular scene shown on the screen, the main objective of the video is to tell the audience about the importance of color contrast. Hence, when the participant says something like, "The man smiles while reading the text message," the evaluator may reject the learning quality. On the other hand, the evaluator may approve the learning qualities when the participants describe something like, "Sun glares at the phone screen, but the text is still readable. The man smiles," which is indicating that there is an importance of the color contrast to make the text readable despite the sun glares. Here I'm showing the graph of the effect of conditions on the mean approval counts. X-axis indicates the mean approval count value, and the Y-axis indicates the conditions. From these figures, we can see that the automated feedback seems to have a positive influence on descriptive and learning qualities, although human feedback seems to have a bigger positive influence than the automated feedback. For the objective qualities, the automatic feedback seems to have a positive influence, while human feedback deteriorates the mean approval counts. Looking at the effect of the video on the mean approval count, the instructional video seems to consistently yield low mean approval counts across quality dimensions. Next, I will be discussing the result of the audio description production time using the interface. The x-axis shows the time in minutes, and the y-axis shows the condition that the participants are in. In total, participants in control condition took 67.6 minutes in average. And while the participants in human feedback condition took the longest, which is about 109.3 minutes in total, including the reviewing time. In automated feedback condition, the participants took on average 60.7 minutes, which also showed a reduction of 45% of production time comparing to the participants in human feedback condition. In summary, we would like to share 3 main takeaways of our study. First, whether to employ a human reviewer or rely on automated feedback is indeed a trade-off relationship. We see that human has a higher effect of improving the audio description qualities, but for the qualities which deteriorate because of the human feedback, such as objective, automated feedback can improve it. This is an opportunity for us to explore the hybrid methods of combining both methods together. Differences of quality responses between different video types encourage us to explore a method to classify the video types a priori. Thus, it will help us to make informed decision whether or not we should hire a human reviewer or whether or not we just use an automated feedback. Lastly, automated feedback is indeed more time effective than human feedback, while at the same time it also helps in achieving good quality of audio description, especially in terms of its descriptiveness, objectiveness, and learning qualities.